indeed gives us back to the correct answer. Okay. All right, one last example. And this has an extra little trick in it. Okay. It is 4 terms, so you might want to look at this and assume, okay, I have to use the grouping method, which may be true. However, you still always want to check first if you can divide out or pull out a GCF. That's always going to be your first thing to check. Check for GCF first. I didn't mention it in the last example. I did mention it in that first example, but I forgot to in the last one. There wouldn't have been a GCF in the last example. However, here we can. You can pull out a GCF. We have coefficients of 10, 5, 10, and 5. So 5 is going to go into all of them. What about the variables? We have an A and A. Well, no A's, can't pull out an A. We have an X, no X's there, so that cancels out the chance of doing it with X. We have a Y, but no Y's here. Okay, it's all mixed up. We have B's here, but no B's over here. There is no variable that's common to all 4 terms. So we can't pull out a variable as far as our GCF, but just the 5. So our very first move then is going to be to factor out that GCF. Okay? So we want to factor it out. So our original expression, if we factored out a 5, divided a 5 out of each of these 4 terms, we'd end up with 5 times 2 would give us the 10, so we'd have 2ax. 5 times a negative 1 would give us negative 5, so we have negative 1ay, or just minus ay. 5 times a positive 2 would give us the 10 there, so plus 2, so plus 2bx. And then lastly, 5 times a negative again gives us the negative 5, and we're going to need a negative by. Okay? So we should have all the same variables in the 4 terms. We're just divided a 5 out of each. Alright, so now what we have to do is look at what's left inside that parenthesis and use grouping inside of it to factor what is left. So we kind of ignore the 5 for right now and look inside and see if we can use grouping on those remaining 4 terms. Okay, so so what's left inside the parentheses, we want to use grouping on. So I'm going to ignore the 5 for right now, and I'm going to group these 2 terms together and these 2 terms together. So we're going to take a 2ax minus ay and a 2bx minus by. So there's our 2 groups in their own parentheses. Want to find 2 separate GCFs now that we've split it up. Here we cannot pull a coefficient out, but both of these terms have an A in common. Looking at these 2, we can't pull out a 2, can't pull out an x or y because both of them don't have x or y, but they do both have a b. So with this, we can now divide that GCF out. So if we pull out a GCF of an A, here we'd be left with A times 2x is going to give us 2ax. And then an A times a minus y is going to give us the minus ay right there. Over here, if we pull out our GCF of a B, B times 2x is going to give us 2bx. And then b times a minus y is going to give us the minus by. Alright. And how do we know we've done it correct to this point? Okay, we have that common binomial. So we know we're good up until now. We just need to write this expression. So we put our two GCFs together, the a plus b, and then the 2x minus y, the common binomial piece, gets its own grouping as well. So that's its own separate factor, and a plus b is its own separate factor. So remember, that's not the final answer though, because we did factor out that 5 to begin with. So, kind of drawing a line from there, that 5 does need to show up out front in our final answer. So our actual fully factored expression would be 5 times the factor a plus b times the factor 2x minus y. Okay. So you might want to leave yourself a little note. The original GCF has to show up in your final answer there. Okay? Because if we were just to FOIL the check and we just did the a plus b times the 2x minus y, if we FOILed that